Good day, class. We're back and we're now on the fourth quarter, and we continue our lessons in statistics and probability. And for this week, we are focusing on the hypothesis testing. And if you would recall, previously we talked about a lot of things, no? Illustrating the student's t distribution, identifying the percentiles using the student's t table, identifying the length of a confidence interval using both the normal and the student's t, computing for the length of the confidence interval, and computing for an appropriate sample size, okay, using the length of the interval, and solving plenty of problems involving sample size determination. Now, for this week, we're going to learn about null hypothesis, alternative hypothesis, levels of significance, rejection region, and types of errors in hypothesis testing. Must be exciting, okay? Identifying the parameters to be tested given a real-life problem. You see, class, we're now focusing and going towards the application of what we've been learning in the past weeks, okay? So if you're ready now, let's get it on.
Welcome everyone to my channel. My name is Mon. Sir Mon.
Okay, let me start with discussing about hypothesis testing steps, okay? Then the first step I would say is to state your null hypothesis. And the null hypothesis is normally the common or the existing population standard which you would like to test later on. And it's denoted by H0, 0 for null, okay? Like for example, the mu is equal to 16, meaning to say the population average is equal to 16, or the population proportion maybe is equal to 65%, okay? And then state the alternative hypothesis, which is the opposite of your null hypothesis. And you can say an example could be that the mean or mu is greater than 16, or the proportion is less than 65%. And then get your data from your survey or other means, okay? And then calculate the test statistics. Remember your z, okay? Z value, the standard normal conversion, is equal to x bar minus mu over sigma over square root of n. You will be using that, okay? And then compare your tabular data based on the error margin or the levels of significance that you would like to use with your test statistic. And then decide to either accept the null hypothesis or reject. For the sake of discussion, I'll be using the word accept to simplify the thinking, no? To simplify the wordings, okay? But basically, statistics would not say accept because we would rather say do not reject or fail to reject, okay? I have a long story about that, but maybe we can talk about it in class, okay? So let's look at the summary. For the null hypothesis, you can have, of course, the HO. This is the hypothesis to be tested, usually stated as equal, greater than or equal, and less than or equal. And it describes the population parameter. Okay, take note of the keyword equal. Okay, the alternative hypothesis, HA, is the possible alternative to the existing phenomenon. It does not have an equal sign. Okay, it's either not equal, less than, or greater than. And it makes two-tailed test if you're going to use the not equal, because when you say not equal, it could be greater than or it could be less than. And it's one-tailed if you're talking of less than or greater than in your alternative hypothesis. Let's have some example, okay? Let's say the mean general weighted average of the Aksai students in probability and statistics, or statistics and probability class, is number 1, mu or mean is equal to 93.75. We have here equal to 93.75. The next one is mu is greater than or equal to 93.75. That means it is at least 93.75. And then the third one, less than or equal 93.75. That means it is at most 93.75. Take note of those words. Huh? So the possible alternatives hypothesis would be For the first one, not equal, and therefore you have the two-tail test. As I have explained, you have the less than and the greater than possibility. And then for the second one, your alternative would be that the mu is less than 93.75. It's one-tailed towards the left of center. And mu is greater than 93.75. It's again one-tailed towards the right of center. Take note, huh? If you notice, the alternative is the opposite of the null hypothesis. Okay? Now, let's take a look at this. It's non-directional because you do not know if it's going to the left or going to the right only. So here you are talking about not equal, not the same, different from. Okay? The alternative that mu is not equal to 93.75 will give you two possibilities. The one on the left and the one on the right. And you know that the center is your confidence level, right? And therefore, if that is 1 minus alpha, your alpha is your level of significance in this case, or your error chance, okay? The level of your error. And we divide it into 2 because otherwise we will exceed 100%, right? And therefore, you divide the total red area into 2, okay? Or meaning to say the alpha, okay? Your level of significance into 2. So you have A or alpha over 2 on the left and alpha over 2 on the right. Okay? So we'll talk about that more later. And then here you have a directional. If you have an alternative of mu is less than 93.75, and this is one-tailed because you're focusing on the left side. So you have those words less than, smaller than, lower than, inferior to, below, decrease, etc. And another directional is when mu is greater than 93.75, also one-tailed because we are talking of only one tail here, if you can notice. And this will be the greater than, bigger than, higher than, more than, superior, above, increase. And you notice, I did not divide the alpha into 2 because there is no alpha or area, red area on the other side. So I only have one area here. So the total of the white is your 1 minus alpha. And if that is the case, the total on the right, which is your red area, should be alpha. And the total of all will be equal to 1. Makes sense, right? So, let's say, I'll give you more example. The average time spent on accomplishing LAS or LAS is 5 hours per day. So, therefore, your null hypothesis would be that mu is equal to 5, right? And the alternative is the opposite, not equal. And therefore, you have this graph. Okay? As you notice, if that is the case, so I have now alpha over 2 here and alpha greater than 2. No. Alpha over 2 on the left, alpha over 2 on the right also. And then 1 minus alpha at the center. Okay? So you end up with 2 tails. Okay? So let's take a look at the next example. The average time spent on accomplishing the LAS is at least 5 hours. When you say at least, it could be greater, right? Because that's the least value. So you have the null hypothesis of mu greater than or equal to 5. And therefore, the opposite, the alternative, you cannot say that the alternative is the same, greater. Otherwise, it's not an alternative, right? So the alternative should always be the opposite of the null. And that would be less than 5. And so you're talking of the left side. And so you have the alpha on the left side. And then you have a left tail. Okay? Now, the next example, if the average time spent on accomplishing LAS is at most. Okay? That is the maximum at most. So it will be less than or equal. Okay? So you have your less than or equal. And therefore, your alternative would be the one that is greater. The opposite of less than or equal is greater than. And so you end up with the right tail test. Okay, so you have your alpha, the one that you're testing, on the right side. Take note of that. Okay, so let's stop for a while and then I want to gauge how much you have understood the just concluded session. Having cleared everything, let us now go to our first activity, a simple true or false. So I have here 5 items. You just write on the chat box whether it is true or false, given the several items that you would read, 1 to 5, right? So just to remind you, better think before you click, and your timer starts now. Let's compare our answer. The first one is that it's a two-tailed, so it is not directional, and therefore the answer is false. Okay. The second one, since the null hypothesis is that mu is less than or equal to 160, why is it less than or equal? Because you're saying at most 160, and therefore the alternative will be the opposite, greater than 160 is true. The third one, of course, it's true because when you say at least, okay, the null hypothesis would say greater than or equal, because that's the least value. And for number 4, when you are using equal sign in the null hypothesis, it will lead to a not equal sign in the alternative, and therefore you end up with the two-tailed test, and therefore the answer is false. And for number 5, if the proportion of girls is said to be at least 58%, and therefore your null hypothesis, okay, will be greater than or equal to 0.58, and therefore the alternative will be the opposite of less than 0.58, and therefore the answer is true. Okay, congratulations to all those who have been able to gather 5 points. Okay, now the level of significance alpha, okay, the one that we've been I've mentioned a while ago, is the probability of rejecting the null hypothesis in favor of the alternative when the null hypothesis is true. So it sounds like an error, right? And the probability of that error is your alpha. And the risk of concluding that the null hypothesis is no longer valid, you want to replace it. And the researcher decides on alpha the level of significance to use. The smaller alpha is used for stricter tests like food, medicines, and chips, you know, the computer chips, because you want to ensure to have a bigger confidence level. So you're putting a smaller risk, okay, or possibility of committing an error. And the commonly used values are 0.01, 0.05, and 0.10 or 0.1. Okay, let's take a look at this table. There are two types of error, type 1 and type 2. Type 1 is rejecting the null hypothesis when, or in favor of the alternative, when the null hypothesis is true. You rejected someone that is true. Oh my goodness. Napakasakit naman. And then the second error is accepting, okay, the null hypothesis in favor of the alternative when, okay, the null hypothesis is false. You accepted somebody who is false. Okay? I want you to remember this. The first one is rejecting. The second one is accepting. How do you remember it? Just remember the first name of your teacher. Okay? And the name, if you spell it, the first letter is R. The second letter is A. And therefore, the first error is type 1 error, rejecting. And the second one, A, accepting. Of course, when I say accepting, it's not the statistically accepted word, but for the sake of simplicity for you to remember, when you say accept, that means you do not reject. So if you look at the table here, you reject when it is true, you have an error. If you reject, that is false, and that's okay, right? If you accept that something that is true, that's also okay. But if you accept something that is false, there you go, you have the type 2 error. How do you make an analogy out of it? Let's say a patient Z has either COVID or not COVID. Okay? And then he either gets vaccinated or not. If you don't vaccinate somebody who has COVID, then you commit a mistake, right? But if you don't vaccinate somebody who has no COVID, then that's okay. And now, the second one, if you vaccinate one that has COVID, that's also okay. And if you vaccinate the one that has no COVID, then you commit also an error. Of course, I'm just using the vaccination procedure here. It does not mean that there is a mistake of vaccinating someone who has no COVID, okay? I'm just trying to make an analogy, okay? If the vaccine is already the cure, okay? Not the preventive. prevention. Okay, the one that you have now is the for prevention. Okay, not the cure. Okay, so in this example, it's just assuming that the vaccine is the cure immediate cure for the COVID. Okay, so don't get confused with that. This is just for the illustration purposes. Okay, now let's go back to the type 1 error alpha. So the alpha is the probability of rejecting the null hypothesis when it is true. So you have here your alpha, and therefore your 1 minus alpha is your confidence level. Okay, and 1 minus alpha is accepting when it is true. So you have the rejecting and the accepting. Okay, rejection, accepting. Okay, so let's take a look at the other one. If alpha is the probability of rejecting null hypothesis when it is true, your beta here is accepting HO when it is false. Now, okay, don't confuse with the first one. Huh? The first one is rejecting when it is true, and the 1 minus alpha is accepting when it is true. Okay, now the next slide talks about probability of accepting when it is false. Now, when it is false, that means you're going to use the next mean. Okay, it's no longer mu1 because that is false. So I will now have a mu2, which is the new mean. And from that, I will have the blue area because your red area is the one that is rejecting. I will now have a blue area based on the new graph wherein the new mean, okay, is using the mu2, okay, as you can see in the graph, and the blue area here is my beta. Okay, that is the probability of accepting the null hypothesis when the null hypothesis that it is equal to mu1, okay, is false. Okay, so let's now go to further interpretation. The 1 minus beta, okay, the one here, okay, above the red area is your 1 minus beta, is the probability of rejecting the null hypothesis when it is false, and that is the power of the test. If the beta is accepting the null hypothesis when it is false, which is your beta here, the opposite of it, 1 minus beta, is the area of rejecting when it is false, okay, obviously the opposite, and that is called the power of the test. Okay, just remember that.